Welcome to MyCC's Tech Out. I am your host, Russ Monastery. Today is not Russ Party for One. It's a party of three. My friends are joining me today. Welcome back, Betsy, Senior Instructor Mentor. Welcome back, Cory, Senior Lead Instructor. Why are my friends here? Linux. I am sure you've heard of Linux, but what is it? Where is it used? Linux is an open source operating system. According to opensource.com, open source refers to something people can modify and share because its design is publicly accessible, which holds much value in the industry. Proprietary or, quote, closed source, which is like Microsoft Windows, right? Only the original authors can legally copy, inspect, and alter the software or code. Compared to open source, authors make its source code available to others who would like to view the code, copy it, learn from it, alter it, or just simply share it. Where did Linux come from? This is a very good question. Where did Linux come from? Linus Torvalds created Linux in 1991. Torvalds built Linux as an open source alternative to Minix, which is a Unix clone used in the education environment. Unix was developed by AT&T in the 1960s. Torvalds originally named his OS, quote, FreeAX, F-R-E-A-X. I think it's FreeAX, but the administrator who was overlooking the distribution server of the original code named his directory Linux after a combination of Linus's first name and the word Unix. Unix had a philosophy which was to create small modular utilities that did one thing and did it well. What is all the hype with open source? First of all, control, right? Manipulation of the source code, right? That's great stuff right there. Training purposes. Programmers and developers can learn new technologies and ways to create or alter applications. Security tends to be more secure compared to other marketable applications. Very similar to Kirchhoff's principle. A crypto system should be secure even if everything about the system except the key is public knowledge. Stability. Compared to proprietary software, open source software will be around a bit longer for those cool projects that those programmers are currently working on. Additionally, open source has less overhead. What about community, collaboration, and teamwork among other developers? Ease of maintenance. All of the distributions of Linux have their own software repository for updates. Now, we also hear a lot about free. It's free. You do not need to pay for anything, maybe a donation if you wish, but you have to keep one thing in mind. You are the support compared to Microsoft, right? Where you have the availability to call tech support. You are tech support for Linux. Speaking of support, the Linux Foundation is an excellent source for support and collaboration for your Linux environment. If you take a look at the link below, there is a lot of information and knowledge to be learned about Linux and about maintaining it. Where can Linux be found? What about those cool self-driving vehicles, smart devices, gaming consoles, servers, mainframes, NASA? Right? Space robots. How about that, the Roku television, in-flight entertainment, smart appliances, the New York Stock Exchange, Department of Defense, the internet, point of sale systems, ATMs, and of course your computer. And there's more out there. Now, what about Linux as a career? Because this is important. Because, people study Linux, people know Linux. What about making Linux a career? According to salary.com, a Linux administrator's salary can range from $59,000 to $120,000 annually, which is about the average, about $97,000, right? Which is pretty good, right? Of course, location and experience contribute to this data. Now, there are different distributions or different flavors of Linux out there. For example, you have Nick OS, OpenSUSE, Kali Linux, Clonezilla, Jing OS, Ubuntu, and there are more out there. If you take a look at the distrowatch.com, that is a great site for you to see all the different distributions of Linux for you to freely download. Now, why are my friends here? Why are my friends here? Cory's going to show us Linux in action, and Betsy's going to give us test-taking tips with LPI's Linux Essential Certification as she recently obtained it. Cory, how are we doing today, Cory?
Great, yourself?
I am doing awesome. All right, Cory, I'm gonna pass it over to you. I want you to show everybody Linux in action. Yeah, go for it.
In action.
Linux in action.
All right.
Excellent.
So let me go ahead and share my screen real quick. All right, here we go. Fasten your seatbelts. We're about to talk about Linux. All right, so with that, I like Hyper-V. Now, Hyper-V is very common in the workplace and, oftentimes used to support VDI, virtual desktop infrastructure. And so the version of Linux that I am going to be demoing today is the 18.04 LTS. Now, the one thing to remember about Linux is that they're not all created equal, right? And so at some points, there is not support as far as updates and so on and so forth. And this is the value of Ubuntu at this point, because it is an LTS version, it's long-term support, right? And so we do get our updates and all of that fun thing, all those different fun things from Ubuntu and the current version, the 20.02 or 1, I think, something like that. And the only reason why I use the 18.04 is because it comes native to Hyper-V. So you do not have to go to a third-party site or anything to go ahead and download the image. So I already have my Ubuntu up and running. So let me go ahead and connect to it real quick, and we'll go ahead and get started. All right. So providing I remember my password, right, we're going to go ahead and get started. All right. So here we go. All right. So first of all, when we look at the desktop, we like Unity as far as the desktop and some of our different file systems as far as GNOME, and just the overall feel of Linux has been super simplified over the last few years. Now, the biggest traction for Linux is everything from cybersecurity to everyday application, right? So I'm going to run through a couple basic operations that I believe will pique some interest. So we're going to do a real world application, and then we're going to have some fun with it, right? And so it all comes back to something called scripting. Now, Microsoft can, do scripting as well through its integrated scripting environment. But Linux uses Bash, which is our born again shell. Now, the shell has been around forever, but we have seen dramatic improvements through the Linux terminal. In fact, we see Windows terminal now that it's being handed down to Windows operating system, which mimics some of the basic operations that we find in Linux. Now, one of the biggest attractions is Bash scripting. Now, scripting is a way that we can automate things and simplify tasks. Most generally, we can use scripting from everything from file creation to directory creation to pulling log information to consolidation to website redirection, the whole 9 yards. The applications of the script is very, very powerful. In fact, hackers will use it in their reconnaissance phase, and so on and so forth to determine the platform that is going to be exploited, right? So there's many, many different applications for Linux. And so let's go ahead and get started. Now, I'm going to go ahead and Control-Alt-T. This will allow me to pull up my terminal. Now, the biggest thing to remember is that, when we first launch a terminal inside of Linux, you are not the root user, right? The root user inside of Linux is very equivalent to the administrator role that we find inside of Windows. Now, this little indicator right here, the $sign here, is an indicator whether or not we're elevated or not, right? And so a lot of our operations that require system-wide change would require for you to actually add yourself to the sudoer wheel. The sudoer is super user do. It's equivalent in Windows to the run as command. So with that being said, if you have to do anything that is system-wide, you would want to be in root or executing a sudo command in precursor to any command that we actually execute. So the purpose is just to kind of show you that scripting is not that bad and how automation can actually simplify your life. So the first script that I'm going to do, we're going to do a real world application of file and directory creation. And then I'll run through a quick script that's a little bit more advanced to kind of show you how much fun Linux can be, right? So with that, anytime we create a script, we have to do so through a text editor. My text editor preference is Vim, which is VI improved. But for this purpose of this demonstration, I'm going to keep everything super simple. And so we're going to use the native onboard text editor, which is called Nano. Okay, so the first thing I'm going to have to do, if I'm going to create a script, I got to create a file, right? So the very first thing is create a file. So I'm going to go ahead and use a touch command. And touch is how we create files. Now, when we do create files and directories, until you get good at the operations of Linux, you should always mount the directory in which you're operating from. So let's go ahead and do that. I'm going to go ahead and change directories, and I'm going to go ahead and go to the desktop. So this actually puts me on my desktop. And, when I do create any type of files or any type of directories, they will reside at the desktop, which for the beginning user is super important to be able to locate your operations, where they're going, and so on and so forth. So that's where it's super important to mount the directory in which you're working. Okay, so the first thing I'm going to do is I'm going to go ahead and create a file. Now, the touch command is how we create files. Now, we can technically create a script without a shell extension, but it is best practice to use a .sh extension so that you can easily identify what's a script and what's not a script. Now, scripts can be very, very dangerous to a machine. And so this is why we want some type of distinction as far as the extension itself. So I'm going to go ahead and touch checkout .sh. So from here, if I did an ls command, you will see that checkout.sh now exists on my desktop. Now, the important aspect of the script itself is to make it executable so that you can run operations, right? So this really does power our overall automation piece that we're seeking to achieve here. So first thing I'm going to do is I'm going to go ahead and understand there's three basic groups in Linux, right? We have the user, we have the group association, and we have the everyone else group. So we can apply execution parameters to this by simply using a +X, or we can revert back to the octal base system, which is a number value that we give back to each individual group. It's always in a set of 3. Now we can use 4 for truncation and sticky bit style operations, but that's a little bit more advanced than what we're going to do today, right? So with that, I'm going to go ahead and switch this file to where it is executable. So first thing I'm going to do is I'm going to go ahead and change mode. Now, change mode is our parameter for adjusting any type of permissions. And I'm going to actually use the easy way out. I'm going to use a +X, and this will give the execution bit and set it for this particular file. And so Linux is very, very linear in the sense that, we identify the operation that we're doing, the parameter that we're going to add, in the actual object in which we're going to go ahead and manipulate. In this case, is going to be the checkout.sh. Now, if we run an ls-l, anything green would signify it is executable. Now, if we were looking over here, this is our string of permissions that have been applied to this particular file. Now, you'll notice that there is an X here, and X here, and that is the detriment of applying the .x parameter in a blanket umbrella type of way. In a workplace, we would want to limit permissions based on, who owns the file, what group association you are in, and the everyone else group, as far as, access control and in many different purposes. Now that we have the file set to executable, we're going to go ahead and open up Nano, which is an onboard terminal-based text editor. Now, this is another attraction of Linux that is often overlooked, the ability to create any type of text doc through the actual terminal itself without actually having to open up a GUI-based text editor. So I'm going to go ahead and run the Nano operation and then specify exactly what file that I want to open. So first, we're going to go ahead and do a fun application of a script first, and then we'll add some different parameters at the end of the script to show you how there is actually real world application that is pretty darn cool. So we start every script with something called a shebang, right? So it's just fun to say, shebang, right? So we're going to go ahead and start off with that. And this is always at the start of any script, and it allows you to determine or identify the script, if you will. So the shebang is the hashtag and exclamation mark, and then we always follow by a bin bash. And so this simply tells the machine itself that, hey, this is a script, and this is essentially, as we outline the script, this is going to be the parameter in which it's going to run, right? So we're going to go ahead and start off with creating an array. Now, an array is basically parameters that we are going to actually call later in the script through different functions such as looping and stuff like that. So the array, we'll call the array tech out. How about that? And so from there, we're going to go ahead and give it the equal parameter, because we have to say, hey, this is what this particular variable equals, right? And so anytime we create a variable, we're going to want to do the open parentheses and so on and so forth. And we'll just do something simple. So we're going to create a basic animation. So we'll do my computer career. So I'm going to go ahead and write this out a couple times. So just be patient. And we're going to go ahead and give it another instance, providing I spell it correctly. And then we'll just keep going, right? So now when we're doing an animation, you'll notice that I am sliding the capital letter through the actual term. And so this may be a long word to go ahead and slide the actual the capitalization all the way through the actual word. So we'll do something a little bit easier. We'll do change, because that's our motto here. Our motto here at MyCC is changing people's lives through innovation and technology training. So let's do that. Let's do change, because that's a short word, and this is going to be a short video. Okay, so we're going to go ahead and do change, and then I'm just going to go ahead and cycle the capital letter all the way through the word. So CHANGE, and then the next instance would be CHA NGE, and then we'll do one more instance or two more instances, CHANGE, and then CHANG, and then a capital E. Now, once I finish the array, I have to close that bracket, right? So this is basically creating an object that could be called later in the script. So the next thing I'm going to do is I'm going to go ahead and create a function, right? So this is truly what's going to power the animation at the end of the day. And so once we're done, it's a simple animation. You're going to be like, all that work for that, right? But it's fun. right? And it shows you the level of manipulation that can actually occur within the actual bash script. And it's really the sky's the limit as far as one's imagination goes, right? So with that, let's go ahead and create our function, and our function will be change. So we're going to go ahead and call this function, and then we're going to go ahead and open our bracket here. And for right here is where we can start our looping process. Now, looping process, there's many different attributes and aspects to the loop, but this one, we're just going to say, hey, cycle through the word slowly to where it looks like an animation. So from here, I'm going to go ahead and create my for loop. And so when I create my for loop, I got to start off with the for, and then I'm going to use the I parameter and the end parameter. And what this is going to do is say, hey, this is going to be the object that we are going to cycle through. And that was what we created with the array. Okay. So from here, I'm going to go ahead and create an open bracket to go ahead and complete the loop itself. And with that, I'm going to call the script or the array that we've already created. And then I'm going to go ahead and curly bracket it, and then basically call the tech out. And then from here, I'm going to go ahead and create a bracket for basically telling it to continually cycle through. And then I'm going to use the ampersand signal to tell it to continue to do it until I tell it to stop. And then after that, I'm going to go ahead and close the bracket. And then I got to close the curly bracket as well to complete the object and complete the quotation mark as well, right? To let the statement actually exist, okay? And so from here, we're going to go ahead and tell it what to do. So we had to use a do statement, right? So from here, we're going to go ahead and echo out, and we're going to use the -ne parameter. Now, the NE parameter is very, very specific to special operations. In fact, it allows you to call other parameters such as reset parameters. And that's essentially what we want in our animation, is the reset between words. And you'll see what that means here in a second. And so I'm going to go ahead and create another function here. And then I'm going to use the \R for the reset. And again, if you use the reset button, it's going to be very, very, very specific to very specific types of looping. Okay. And in this case, it is absolutely necessary for what we are trying to achieve here. Right. And so I'm going to use the I parameter, and then I'm going to go ahead and close it. And then from here, we're going to go ahead and say, hey, don't do it fast. We actually want to see it, because if we don't tell it how fast to go, it's going to cycle through in milliseconds. It's going to be boom, and you're not going to be able to see any change whatsoever within the loop itself. And so I'm going to go ahead and create a sleep parameter of a point. Let's just call it a 0.9 seconds, right? So this way you can actually see it on the screen, and so on and so forth, right? So from here, I'm going to go ahead and put done, and then I'm going to go ahead and close my bracket as well, because remember up here, we had our bracket that started our statement, and now we actually have to close it, okay? So from here, we got to call the script. And so our script, our loop here is going to be tech out, okay? And so, or actually, we actually called it change. So we're going to call our function change here. So we actually have to call this in. Now, I'm going to go ahead and just put change down here. And then if I do not exercise some type of echo parameter after this, my syntax will actually follow it. And so if you want a clean loop, a clean animation, you have to tell it to stop, break, okay? And that's what I'm going to tell it to do right now. So I'm going to go ahead and do an echo, and then I'm just going to do a parentheses. I'm going to Control S to go ahead and save it. You'll see that it wrote 17 lines, and then I'm going to go ahead and Control X and get out of it. Now, if I wanted to call the script, right, from the current shell and the current directory that I'm working at, I would use a /. And so in this case, it's called techout .sh. And so you can kind of see it cycling through what we told it to do, and is doing it without the actual syntax following it. So if you didn't catch it the first time, let's go ahead and do it again, right? So I'm going to go ahead and call the script again. Now watch underneath, and basically we created a text animation, right? And so let me go ahead and call that real quick in checkout.sh, and notice that the capital letter is actually cycling through the word, right? So this is something that I came up with. I didn't even really prepare for this tech out. And this is just, when we understand basic operations such as looping, whiling, and some of the other different things that we can do, the imagination is essentially, sky's the limit. In the classroom, I like to teach storyboard scripting and stuff like that, creating games. That way you can pass it on to your child and actually get your child into scripting as well. But you may be saying, Cory, there's no real world application for animation, right? So let's go ahead and add a basic real world application to this script. And we're going to go ahead and throw up, I don't know, let's do 10 directories, in an automatic fashion. And then we'll end the actual demo there. All right. So I'm going to go ahead and nano out, and then I'm going to call the script again. So I'm going to do a checkout.sh. And notice that I'm back here, but notice that I'm at the top of the line at the shebang, right? And so I'm going to go ahead and cycle back all the way down. And then from here, I'm just going to go ahead and use a real world application. I'm going to go ahead and give it another space. So it's best to put comments in all your software scripting, whether it's Python, whether it's Java. You should always comment any change in that script or in that software. That way, if somebody goes in and modifies it, there's actually like a directory of all the changes and what's actually occurring in the actual software, right? So my favorite is Python. I love Python. You can do so much with it, but from a hacker standpoint, from a cybersecurity standpoint, from a system administrator that's actually working in a company, Bash is the way to go. And so it's definitely the easiest one to learn. And so we're going to go ahead and do an mkdir. And so mkdir just simply is a make directory. This time, I'm going to actually do it a little bit more advanced. I'm going to do a parent directory, and then which is a -p parameter. So basically what this means is I'm going to create a folder, i.e. a directory, but I'm going to create a hierarchy of directories. And so I'm going to do 1, 2, 3, 4, 5, 6, and it will actually, 1 will reside in 2, 2 will have 3, 4 will have 3, and so on and so forth. It will be put in a hierarchical fashion. So we'll just go ahead and outline this. 1, 2, 3, 4, 5, and 6. And we're going to go ahead and Control S to save it. We wrote 19 lines, Control X, and we're going to go ahead and call the script back up, /checkout.sh, and we will see our automation occurring. Oh, look at that. Animation done by Cory. I'm just saying, right? And so from there, what happened to the directories? I don't know. Let's look. Let's see what happened to our desktop. And so boom, there's 1, 2, 3, 4, 5, and 6, right? So we can create directories. We can redirect standard output. We can redirect error output. There's so much you can do with Linux. It is absolutely fascinating. I hope you enjoyed all this, Russ, and anybody who's watching. Betsy.
Man, that was awesome, Cory. That was awesome. And at the same time, I'm afraid because I'm a Windows guy, and I don't think I'll ever be able to do stuff like that. And any certification that I've done in the past, and if there was Linux involved, I always got very nervous. But that was really cool, Cory. Thank you so much for that. Thank you so much. Betsy has recently reached her goal of passing the LPI Linux Essentials certification, right, Betsy?
Yes, sir.
Can you provide us with some test-taking tips?
Well, sure. It's just about making sure that, you're really prepared to go in there and feel comfortable with the material. And here at MyComputerCareer, I used all the tools that we give our students so I could prepare for it just like they do. I watched the Skillsoft video trainings for Linux and made sure to take plenty of notes on those, They go into great detail on there. I made some bullet point notes, took down the things that were going to be relevant for the exam. And it was really helpful for me to get ready for that. Along with that, I used the LPI objectives for the Linux Essentials exam, and I made a big study guide for myself. So I would be able to go through that on a regular basis, to get ready for the day I was going to test. We also have hands-on labs here through Skillsoft, and I found those really helpful because everything that I was able to learn in the video training, everything I took notes on, I could then apply using those video trainings, because it's a lot different just to hear somebody talk about Linux and take notes on it, but then to be able to go in and do those hands-on labs through Skillsoft as well, where you can actually apply what they've talked about in the videos. It really helps to sink in so you understand what it is they're talking about. So I use that a lot. In class, we always set up virtual machines and use the Linux Ubuntu. And I used I spent a lot of time in there using that as well before I would go in and take the exam. Once you go in and set it up, you can go through and start practicing all the commands that you need to know for the exam. You can go around and you can start playing things like Cory just showed you. You can go in there and do those yourself. And that really helps you to understand what Linux is, what it can do, and all the possibilities out there. So I think that was really what I took in before taking the exam, and I ended up having really good results.
That is some really good information, Betsy. Thank you very much. And for those that are going for these certifications, going for your LPI Linux Essential, going for any CompTIA certification, these test-taking tips do carry over from certification to certification. So definitely take advantage of it. But Betsy, Cory, thank you so much for your time. We had a lot of fun, and I am still afraid of Cory's demo because I cannot do that stuff. But again, thank you very much. If you liked this video and want to see more Tech Out, give us a thumbs up and subscribe. Also, leave a comment on what IT topic you'd like us to cover next on Tech Out. Let's continue our conversation at Cybersecurity Lounge. I would love to hear from you. As always, with cybersecurity, be aware, be safe, and be cyber smart. We'll talk soon. Thank you very much.